Hi there, welcome back. Today we're going to look at section 6.2, which is on integration by substitution. So far we've been doing our integration with just our four rules that we basically know of. Okay, and they're listed down here on this section as well. So we know how to integrate a constant. We know how to integrate the powers when we have a term raised to a power. We know how to do 1 over u, which is the natural log, and we know how to integrate e to the u. So today what we're going to do, we're going to take some harder problems that we don't really have a rule for, and we're going to use this method called substitution. Specifically, we call it U substitution. We'll talk about that in a minute. But we're going to create an easier problem given a harder problem. And the easier problem will be one of the methods that we already learned in the last section. So part of this is just knowing that we're trying to get down to something we already know. And then the other part of it is knowing that in this substitution, you're going to be doing integration as well as finding a derivative. So it's a little confusing at first because we're doing both things in order to integrate, but hopefully you'll see that the steps involved are always the same. And once you do these steps several times, you'll start seeing the pattern evolve. Okay? All right, so all we're going to do today is work on how we do this U substitution. Okay, we're going to use this integration by substitution method. We're not going to do any word problems or anything today. We're just going to work on basic functions, and we're going to find the integrals. Okay. All right, so your concepts and definitions. The biggest thing is knowing kind of what we're getting ready to do. So this integration by substitution restates a formula of integration with function notation by making U substitutions as follows. All right, so what we're going to do is we're going to let U equal a function. And that function is going to be part of the problem you're given. And then you're going to take du, which remember is the derivative. This is the differential, which is a derivative. Okay, so you're going to take the derivative of the function you took and then times dx. Because again, when we're doing the derivative with respect to x, we have to do the dx. Okay, so I don't think on your notes you had the times the dx there, so you might want to put it if that's going to help you remember what we have to do. All right, then again, once we do the U substitution, we're going to end up with one of the four things that we already know how to integrate. That's what we spent the last section doing. Okay, you'll notice the only difference here is that our x's now say u. Okay, if you look back on the last section, you'll see these four exact integration rules, but we did x. So it was dx, and then we had x to the r. Okay, so other than that, everything is pretty much the same. So that's that u substitution that's going to come into play here in a minute. All right, then number 3 says any substitution made by an integrand requires a related substitution for the differential. So that's why we have to do dx up here, because we're going to be substituting in for du in the, we're going to be substituting in for dx in the problem with the du that we're going to take in a minute. Okay? All right, so let's kind of just remember the rules for integration. The integral of a constant is just the constant times, used to be x, now it's the constant times u. U to the r, remember you add 1 to the exponent, put it in the denominator, and then you raise the exponent to add 1 to the exponent as well. You're going to do that for any power except if r is -1. If r is -1, then this is what you have, 1 over u. And so that is the natural log. So the integration of this function would be the natural log. And then e to anything, remember the integration is e to the anything, because those are both the same as far as going backwards and forwards, right? All right. So number 4 says the U substitution method should be used when, in order to check the correctness of an antiderivative found, you must use the chain rule. So you'll see that as we go through today. Once we get our integral done, we'll see that in order to find it, we have to use the chain rule. So the big thing about integration is there is no product rule or quotient rule. Okay, you have to do this, use substitution. It's probably the most important, one of the basic things we do when we integrate. So if we can't do one of the basic rules, typically use substitution is the first thing that you're going to go to. Now, here's the rule of thumb when you're substituting in for u. Okay, what are you going to let u be in the problem? So u is either going to be what the exponent is if it's a function, okay, in an exponential function. We're going to use any expression that's in a parentheses. We might use what's in the denominator. And then an expression under the radical sign, to me, is the same thing as the exponent in an exponential function, because you can write this, right, as an exponential function. The exponent, instead of using a radical, you can raise it to a rational exponent. So these are kind of the same thing. I usually will change all my radicals anyway to something raised to a power. Okay, now I'm going to add one other thing down here as part E. And this is just to make sure you guys don't ever make this mistake. But you're never going to let u equal x. You're never going to substitute x for u. That doesn't help you one bit. What you're trying to let u be is a function that's harder in the problem. If you just let u equal x, then you're not doing anything to the problem. So that would never be a choice for you for your substituting. Okay, never substitute in a u value for just plain old x. All right, now, when you do these things, okay, what we're going to see is that when you take the derivative, because remember we have to take the derivative once we have u, so what you take the derivative of, that part has to also be in your original problem. Okay, that's what we're looking for. But it only has to be in your original problem up to the constant. So your constants can be different, but everything else has to be there. Okay, so I'm going to write here, let u equal something. Okay, we'll see that in a minute. I know that's very vague, but something such that du, which is the derivative, okay, du is also in the problem. I'll put in the original problem. Okay, up to the constant. So the constant does not have to be there, but everything else does. So that's kind of important, as you'll see when we go through this problem. Because remember, if you're doing an integral and it's just a constant, you can always bring those constants right out front. They just stay in the problem, right? So that's a good thing because we don't have to worry about that so much, okay? All right, so let's kind of work on this and let's go through. I'll give you some steps. Some of you guys like to have the steps. So as we do first problem, let's go through and look at those steps. All right, so the first step you want to do, step 1, I'm going to write it over here. Okay, step 1 is going to be find u. So we need to figure out what u is going to be. So in our problem, here are things in the parentheses, okay? Typically you're going to pick the higher or harder thing, but if you look, and I take the derivative of this term, right? The derivative of 3x to the 8th is 24x to the 7th. The derivative of 6x is 6. So do you see I have that here? So this is the derivative of this. So I want to make sure that what I'm taking as u, the derivative is going to be in the problem as well. So I don't want this one to be u, because if I take the derivative of it, it's not going to be in the problem. So we're going to let u equal 3x to the 8th plus 6x minus 4. Okay, so we found our u. Step 2 is going to be find the derivative. So find du. Okay, so step 2, the derivative of u is 1 du. The derivative of this side, okay, power rule, 8 times 3 is 24. Subtract 1 from the exponent. Derivative of that linear term, 6x is 6. And then dx. You always have to put what you're finding the derivative with respect to. So on this side, we're finding the derivative with respect to u. On this side, we're finding the derivative with respect to x. Okay, so the derivative of u is 1 du. We just don't need to put the 1 there. And the derivative of this side is 24x to the 7th plus 6 dx. So I'll put that in parentheses so you kind of see that. Okay, so you're always going to have this tacked on to the end. Okay, all right. Step 3, okay, is going to be your u substitution. Okay, u sub. All right, so we're going to go to the problem. Okay, notice what this is u. So we're going to substitute in u for this. So we have u to the 1/3. Okay, can't forget that. Then 24x to the 7th plus 6 dx is right here. So we can substitute in this because that equals that. Okay. All right, so that took care of everything in the problem that I needed to. Everything has to be accounted for. Okay, so this is, I say easy, it's not easy, but this is just your very basic one where everything is right there in front of you, so you don't have to do any kind of manipulation with anything. They're not all exactly like this, so we'll get a little bit harder as we move on. All right, now step 4 is to do your integration. So we're going to integrate. Okay, this. All right, so this is a power rule. So remember when we integrate, we're going to add 1 to this. So 1/3 plus 1 is 4/3. And you divide by that number, right? Okay. So we added 1, goes in the bottom, and then we raise it to that power. Okay. All right, and then what do we do when this is an indefinite integral? We put plus c. All right, so that's step 4. And then the very last step is to substitute back in the original problem. Okay, so substitute original back in. Okay, so we're going to substitute in, instead of u, we're going to substitute what the problem had, which was 3x to the 8th plus 6x minus 4. So the last step is to use that substitution. So putting in back what u was equal to. Okay. And then we're going to simplify that. So for dividing by 4/3, remember, that's just multiplying by 3/4. All right. So there's your answer. Okay. Now, the nice thing about this, remember, is you can always check. If you were to take the derivative of this, okay, 4/3 times 3/4 is 1 of these to the, subtract 1 from that to the 1/3 power, so that is a chain rule, and then times the derivative of the inside, which is that. All right, so if you took the derivative of this, you would get that, except for the constant. We don't know what the constant is. Okay. All right, so that's a basic u substitution problem. And notice we ended up with integrating something that we already know how to do. We do not know how to integrate that. So we took a really hard looking problem, made it pretty easy by finding the right thing to pick for u for substitution. Okay. All right, let's try B. Now B is a good problem because we have a constant that we're not going to see in our derivative. So this is where I put earlier that you want u to be something such that du is also in the problem, okay, except may or may not be the constant. It could be, but might not be. Okay? All right, so let's look at this problem. So remember, what are you going to let u be? U is either going to be the exponent, if it's not just a number, something in the parentheses, or something in the denominator. So in this problem, step 1 is going to be to let u be what's in the parentheses. That's all I really have. Okay. I don't want to pick an exponent without an x in it. I mean, I'm picking u to be something that's difficult looking. Okay. So typically what's in the parentheses. All right. So now we have to differentiate that. So derivative of u is 1 du. The derivative of 5x is 5. Derivative of 3 is 0. And then times dx. Okay. Now let's look at the problem because here's where that constant comes into play. We're saying that du is 5 dx, okay? I have the dx, but I have a 6. I don't have a 5. And I can't use that 5 because that 5 is part of the u, right? That parentheses. So this is the only thing I have. So because the constant is not this constant, we just want to move this over to the other side. We just want dx by itself. So we're going to divide both sides by 5. So if you divide both sides by 5, you're going to get 1/5 du equals dx, right? So if you're dividing by 5, divide this by 5. I just write it as a fraction here because I need to keep the du separate. So just write that as a fraction if you have to divide it over. So instead of 5 times dx, I divided by 5. So du divided by 5 is the same thing as 1/5 du. All right, so now this is what dx is. So we got to keep that in mind. So that's up to that constant. Okay. All right, step 3 is to do the u substitution. Okay, so we're going back to the problem. So 6 is there. It's not part of my number. So remember, constants just stay where they are. If they're not part of the du, just leave it in the problem. That's okay. Constants don't have to be part of these two steps here. All right, then we're going to substitute in the 5x plus 3. That was our u to the negative 2. And then what was dx? So dx now is not just du, it's 1/5 times du. I always put the fraction separately from du because du has to be, typically it's always the last thing in your problem. Because I want you to see that you actually have to multiply here. Okay, so 6 times 1/5 is 6/5. That can come out front when you integrate. You don't have to have constants in there. They just stay with the problem. Okay, so really only have to integrate u to the negative 2, which is again the power rule. And then whatever I get, I would just multiply it by that constant. So that's why it's okay if this is not part of your steps 1 and 2. Okay, but this is important that you make sure what you solve for over here is either in the problem or you just want it to be dx and move the number over. If that was a 5 right there, then I would have just left it like that because I could have substituted it in. Okay, we'll do some more of those so you'll kind of hopefully get the hang of that. All right, so now we're ready to differentiate. So 6/5 is going to stay. And now what's the integral of u to the negative 2? So the antiderivative, I would add 1, goes in the denominator, and it change that numerator. So if I add 1 to negative 2, I get negative 1, and I get negative 1 in the bottom. And then I would do plus c. Okay? All right. So we're going to simplify. So this is negative 6/5 u to the negative 1 plus c. Okay, so simplifying it. Now, I think on the last problem, just want to let you know, I substituted in and then I simplified. It doesn't really matter. You could sub in and simplify. I typically, I guess I did that one probably not the way I normally would have, typically would have wrote 3/4 u to the 4/3 and then substituted that in, but it comes out the same either way you do it. All right, so I simplified first on this one. Now I'm going to substitute back in step 5, which is putting in 5x plus 3 back for u. So negative 6/5, 5x plus 3 to the negative 1 plus c. So there's your answer. Okay. Pretty sure Hawks will take it that way. Or if you want to write it with a positive exponent, you would just put this in the bottom. So you could write it this way. Same exact thing. okay? But Hawks will take it if you just leave the negative exponent, right? So either way is perfectly fine, okay? All right, let's look at part C. All right, for part C, again, when I see the radical, I'm going to write it using a rational exponent, okay? I just rather do that. So I'm going to write it negative 2y and then 3y squared plus 5 to the 1/2 power dy, okay? I just like to do this, keep it consistent, and it's just easier when you're taking derivatives and so forth, okay? All right, so remember, what are we going to let u be? Okay, I don't have a denominator. I don't have an exponent with an x in it. So I'm just going to let u be what's in the parentheses, 3y squared plus 5. Okay, so that's step 1. Step 2 is to find du. So that is 6y. Derivative of 3y squared is 6y. The derivative of 5 is 0. And then we have to do times dy. Okay, now we did we did not do dx because this has y's in it. So it's whatever this is, that's what we're taking the derivative of. Okay, now is 6 in the problem? Okay, here's u. So notice in this problem I have a negative 2. Okay, I have the y, and I have the dy, but what I don't have is the 6. So let's move the 6 over to the other side. So we're going to divide both sides by 6. So we end up with 1/6 du equals y dy. Okay, so you just check it. Once you get to the derivative, if the constant isn't the same, move it over. Keep the things that are in the problem. So you do have the y and you do have the dy. So we want to keep those on this side because we can substitute those in. All right, so now we're ready to do our integration. So let's sub in. Let's do our u substitution now. All right, so the negative 2 is going to stay. Okay. All right, then we've got this, well, let me use the fraction. So we've got the 3y squared plus 5. So that's going to be u. Yep, just said that. That's going to be u to the 1/2. Okay, so I got the negative 2. This came out. I have this. So now look at what's left in here is y dy, which I have. Y dy is 1/6 du. So 1/6 du. So that takes care of everything in the problem, and now I just need to simplify it before I integrate. So I've got negative 2 times 1/6, that's negative 2/6, which is negative 1/3 u to the 1/2 du. Okay. All right, so now we're ready to integrate. The negative 1/3, the constant just comes out front, and we're just going to integrate u to the 1/2. So we're going to add 1 to the exponent and put it over that number. So add 1 to 1/2, we get 3/2, and we're going to divide by 3/2. Okay, plus c. All right, so let's simplify first. So negative 1/3 divided by 3/2 is the same thing as negative 1/3 times 2/3. So negative 1/3 times 2/3. Okay, that's what we're doing. When you divide by 3/2, you're multiplying by that. So that gives you negative 2/9. So negative 2, I say things, but I'm writing them wrong. So negative 2/9 u to the 3/2 plus c. Okay, so that's our antiderivative. And remember, the last step now is to substitute back in for what u was originally. So 3y squared plus 5 to the 3/2. Okay, so there's your answer. And again, you can take the derivative of this. 3/2 times negative 2/9, that would be negative 1/3 of these to the 1/2 power times 6y, right? The derivative of the inside. And that 6y would reduce with that negative 1/3 to give you that negative 2. So you can always check your answers taking the derivative and making sure it's what you started with. Okay, except for the constant. We just have that. We don't know what that is yet. They're not giving us any specific values like we ended on the last section with. Okay. All right, let's try part D. All right, so what's in the parentheses? That's going to be u. Then we're going to take the derivative. Derivative of x is 1 dx, right? You can put the 1 there, but we don't have to. Derivative of -2 is 0. So that's our derivative step. Okay, so there's step 1, step 2. Step 3 is to do the u substitution. So in place of x minus 2, I'm going to put u. And in place of dx, I put du. So there was nothing else in there I had to worry about. So this one's kind of straightforward. All right, so now we're going to integrate. So add 1 and put it over that number. So if you add 1 to -6, you get -5. Put it over -5 plus c. Okay? All right. So we can kind of simplify that if you want. Bring the -1/5 out. U to the -5 plus c. Simplify it that way. And then substitute back in step 5. Put in what we let u be. So u is x minus 2 to the -5 plus c. And again, you could put the x minus 2 to the +5 power in the denominator if you want. That's okay. All right, but again, look at your derivative. -5 times -1/5 is +1 to the x minus 2 raised to the -6 power. And that's what you started with, okay? So you could always check these if you need to. All right, let's look at part E. All right, now, we don't have parentheses, but we have a denominator. And that was the other rule for u, is let u equal the denominator, not the numerator. Remember those possible things. You want to let u be what's in the parentheses, what's in a denominator, or what's the exponent. Okay? All right, so du is 2x plus 5 dx. Right? That's the derivative. All right, now, if I'm looking at this problem, I've got the bottom, but if I look at the top, I'm kind of seeing that I do have that. So let's look over here and let's factor out something from the top. Both 4 and 10 have a 2 in common. And if you factor out a 2, you do get 2x plus 5, right? So typically you guys can get problems where things are going to happen like that. So now I see that I do have that, but I'm missing the 2, but that's fine. Remember, constants don't matter. They just stay in the problem anyway. So I have everything I need. I have 2x plus 5 dx that I can get rid of. This is going to be my u. So everything is good to go in this problem. Okay. So step 3 is to do my u substitution. Okay. All right. So again, 2 is going to stay in the problem. Okay. Then I'm going to put in the u, which is in the bottom. And then 2x plus 5 dx is going to be my du at the end. So that's what I have. Everything's accounted for. I'm going to bring the 2 out front so that you can see what I have here. Okay, so the constant just stays in the problem. That's a nice integral to take. 1 over u, if you integrate that, the antiderivative is the natural log of the absolute value of u, and then plus c. And then lastly, that's my integrating part. Okay, lastly, we're going to substitute back in. So we have 2 times the natural log of the absolute value of x squared plus 5x plus 2 plus c. Okay? And again, if you took the derivative of this, it would be 1 over that. And then in the numerator would be 2x plus 5, but then you have times this 2, which gives you what we started with. Okay? All right. So hopefully you're seeing that it's pretty consistent on what you have to do. We just need to make sure that we are starting with the correct value or the correct substitution for what u is equal to. Okay? All right. I'm going to pause here since it's been about 30 minutes, and I'll pick up again in our part 2 video. See you back here in a sec.